Yo, what's up everyone? It's Ravi back with another video. And today we're diving deep into the world of machine learning. We're talking about how Netflix seems to know your taste in movies better than your best friend, or how self-driving cars are even a thing. We're gonna break down each type, see how they work, and look at some real-world examples. So, if you've ever wondered how AI actually learns, stick around, hit that subscribe button, and let's unravel the mystery. First up, we're tackling supervised learning. Imagine you're teaching a kid how to tell the difference between different fruits. You hold up an apple, you say apple, then you show them a banana, you say banana. That's essentially what we're doing with supervised learning. We're feeding the machine labeled data, basically showing it tons of examples with clear answers. So the machine learns from this labeled data and starts to see the patterns. It's like, okay, if it looks like this and has this label, the next time I see something similar, I can guess what it is. Let's take spam email detection. The way your inbox knows to filter those out is through supervised learning. The algorithm was trained on tons of emails, some labeled spam, some labeled not spam. It learned to recognize the patterns, the keywords, the sketchy sender addresses, and now it can pretty accurately predict whether a new email you get is going to be junk or not. And it's not just spam. Think about medical diagnoses. Doctors are using machine learning algorithms trained on huge data sets of patient information, symptoms, test results, you name it. The algorithm can then analyze a new patient's data and help predict potential diagnoses. Or how about predicting stock prices? By analyzing past stock market data, these algorithms can start to identify trends and make predictions about where the market might be headed. Now, no one can predict the future perfectly, but these algorithms are getting pretty darn good. Alright, moving on to unsupervised learning. Think of it like giving someone a giant jigsaw puzzle but without showing them the picture on the box. They have all the pieces, but they have to figure out the connections themselves. That's unsupervised learning in a nutshell. We're giving the machine data, but this time it's unlabeled. The algorithm has to find the patterns, the relationships, the structure all on its own. One of the coolest applications of this is customer segmentation. Let's say you're running a massive online store. You've got millions of customers with different buying habits, preferences, all that. Unsupervised learning can group those customers into different segments based on their behavior. By understanding these segments, you can tailor your marketing, your product recommendations, the whole 9 yards to give each customer a more personalized experience. And speaking of personalization, unsupervised learning is the magic behind those recommendation systems we all know and love. You know, like when YouTube suggests a video that you end up watching even though you've never even heard of the channel before? Or when Spotify seems to read your mind and create a playlist that's perfectly tailored to your current mood? That's unsupervised learning, picking up on subtle patterns in your viewing or listening history and finding connections that you might not even realize are there. And for the security conscious out there, unsupervised learning is also playing a huge role in anomaly detection. Think about credit card fraud. The algorithm can analyze millions of transactions looking for anything out of the ordinary. Whatever it is, the algorithm can flag it for potential fraud and help keep your information safe. So, we've covered supervised and unsupervised learning, but what if I told you there's a third option that kind of combines the best of both worlds? Enter semi-supervised learning. It's like having that jigsaw puzzle, but this time, you get a few of the pieces pre-assembled, giving you a head start. You have some labeled data to guide the algorithm, but the majority of the data is unlabeled. Think about speech recognition systems like Siri or Google Assistant. They're constantly learning and improving, and they do that through a combination of labeled and unlabeled data. The labeled data might be transcribed audio recordings where someone has gone through and manually labeled each word. But then they also have access to tons and tons of unlabeled audio, just raw conversations, podcasts, you name it. By combining these two types of data, the algorithm can learn much faster and more effectively. Another great example is web content classification. We're talking about organizing the entire internet, categorizing websites based on their content. You can label a small subset of websites, just enough to give the algorithm a basic understanding. Then, the algorithm can take that knowledge and apply it to the vast sea of unlabeled websites, categorizing them with impressive accuracy. Finally, let's talk about reinforcement learning, or RL for short. This one's all about learning through interaction and feedback. Imagine you're teaching a dog a new trick. You give them a treat when they do something right, and maybe a little no when they get it wrong. They're learning through trial and error, figuring out which actions lead to those tasty rewards. RL is kind of similar. We have an agent, which could be anything from a self-driving car to a character in a video game. This agent interacts with its environment, taking actions and observing the consequences. If the action leads to a good outcome, it gets a reward. If it leads to a bad outcome, it gets a penalty. The agent's goal is to maximize its rewards over time, and it does that by learning from its mistakes and figuring out the best course of action. One of the most well-known examples of RL is self-driving cars. These cars are constantly taking in information from their surroundings, making decisions about when to accelerate, brake, turn, all that. Through trial and error, hopefully in a safe, simulated environment at first, the algorithm learns to navigate roads, obey traffic laws, and avoid obstacles. And then there's the world of game AI. You've probably heard of DeepMind's AlphaGo, the AI that beat the world champion at the incredibly complex game of Go. The algorithm learned to play Go at a superhuman level, simply by playing against itself millions and millions of times, learning from its mistakes and refining its strategy with each game. But RL isn't just about games. It's also being used to train robots to perform complex tasks in the real world. Alright, so we've covered a lot of ground today. We've seen how supervised learning uses labeled data to make predictions, how unsupervised learning uncovers hidden patterns, how semi-supervised learning blends the two, and how reinforcement learning learns through trial and error. Machine learning is no longer a futuristic concept. It's here, it's now, and it's powering so much of the technology we use every single day. From the recommendations you see on your favorite streaming service to the algorithms that keep your inbox free of spam, machine learning is making our lives easier, safer, and more efficient. So, which type of machine learning fascinated you the most? Let me know in the comments below, and while you're there, hit that like button and subscribe to Virtual Visions for more deep dives into the world of AI. So, to recap, supervised learning equals labeled data, clear instructions. Unsupervised learning equals finding hidden patterns. Semi-supervised learning equals a bit of both. Reinforcement learning equals learning from actions and rewards. See you in the next video.